Hello and welcome to another episode of the Clojure Pills screencast. This is episode number 11. We're going to see the count function. But before we start, as usual, a quick mention of the fact that these screencasts are based on the Clojure standard library and annotated guidebook that I'm writing for Manning. The book is a work in progress at the moment, but a few chapters are already available, and a few samples are also available if you want to check how it looks like. I have a 42% discount code that you can see on screen at checkout, and below is the homepage of the book. And farther down is my Twitter handle at reborg if you have any questions, if you want to get in touch. So count, let's have a look at the Clojure doc. It's got one argument, a call, a collection, usually a Clojure collection, and it simply returns the number of items in the collection. And it's got a few corner cases, a few things you might be interested in. One of them is count nil returns at 0 as a default. There are others that we're going to see now. And it also works on strings, arrays, and Java collection and maps. So how can we use count? It's a pretty common function. So I suppose even if you just started with Clojure, count might be one of the very first things you use. And it's also very simple. So it obviously works on vectors and lists and things like that, and it counts the elements in them. But then each type counts in a different way. For example, if we use it on hash maps, we are counting the pairs. We are not counting each key value that you can see visually in the map. We're just counting the pairs of them. And similarly, I can count on records. For example, I have a can I count record here with 3 fields, and I can count them. So it's not necessarily a very useful thing to do, but you can count on def records as well, and each type is counting in a slightly different way, or it can be counting in a slightly different way. This is also telling us that count implementation is essentially delegated down to the specific collection type, and there are several good reasons to do that, and one of them is performance and keep them in good shape. A few corner cases, so that you can count a nil. That's not a problem, it's not an issue, and it's printing a 0. Keep that in mind, but it's usually not a problem as part of like the nil punning semantic of Clojure. So you can keep counting on, for example, calling next on an empty collection, that returning nil, and that won't throw an exception, for instance. And this is a more interesting corner case. So what happens if we try to count a range, so a collection of elements that has more than integer max value number of elements, and we can see that this is throwing an integer overflow arithmetic exception. And this is interesting because what count is returning is Java lang integer, and it's usually not the case. In Clojure everything is a long usually, but it's not in the case of count. So if you try to count on a range in this case, or in more general, a collection that has more than the integer max value elements in it, then you might encounter the integer overflow. So it's not very common to have such a large collection to count, and is it not even possible for arrays, for instance, that they don't allow for indexes more than integer max value in any case, so you won't be able to create the array in the first place. But it's something to keep in mind if you're doing count on ranges, like in this case. And yeah, now for the corner cases. I want to present like an example of count. Count is clearly ubiquitous, is used in many places, is used for example, batching to batch up things into slots of the same amount of elements, is used in math operations like average, is used is used in many ways and is very common. So there are a lot of examples I can present, and I just selected one that is very simple to show. So I have a copy function here that copies files from one location to another, and I want to connect this copy function to a main function that then I can invoke from the command line. So it's typical for command line apps to verify or validate the input arguments, and is one of those cases where you might see count used, and this is exactly the case here. I created this main function that is checking the number of arguments, and based on that is doing different operations. And this is because my copy function takes at least 2 arguments and 1 optional last argument. And so I need to verify that there are at least those 2 arguments by counting them, and it should be more than 2. If not, I'm going to print like the usage, how you are supposed to use the command line utility. If it's got 2 arguments, then I'm executing the copy, and if there is an additional argument, then good, I'm taking that, but I'm leaving, actually that was meant to be a different thing, like nth of 2. So I'm sure I'm taking the last argument, but if there are more than 3 arguments, I don't really care, and I'm just ignoring everything after the third. And that should be okay. So I'm evaluating this function, so we don't have, in this case, all the project plumbing to compile and create a jar and show you that this main can actually work. But you can trust me on that, or just use Leiningen or Boot or other build tools, and that will make your life very easy to create this command line utility. So I'm going to invoke the main function directly, simulating a command line invocation. So I'm going to try the main function with 2 arguments. We can also try it with like no argument to see that it's actually printing the way I'm supposed to copy one file to another location. And I can try it with the 3 arguments, and of course my change here didn't work. So nth to args array second number, it's because, let's check, I think nth might be taking the collection first, and that's exactly the case. So sorry for that. That can happen sometime. Let's try again with 3 arguments, and it should be working as expected. We can verify that. We open another terminal, and I should be able to see that I was able to copy the project CLJ and also copy that file into another file called copy2. So the details of what the third argument means is that I'm giving, I'm considering the working directory, the working folder, the current directory, as you can see here in the copy function with 2 arguments. If I'm passing a third argument, I'm considering that the working directory, and this is because the first argument, which is the from file or the input file, is considered to be it is a relative path and is considered to be absolute in the current folder or in the folder that you specify as the third parameter. So it's not really important to explain how count works. What we can concentrate on is the way this cond is structured to select different things based on the number of arguments. Very easy way to use count. Interestingly, there's also another function called counted in the standard library that is telling me if a collection type is able to count in constant time. And we can see that is giving me true for most common collection types. It's not always, though, giving me true. Sometimes it's giving me false. For example, for lazy sequences, where the count is not known at the time of the creation of the lazy sequence, then the only way to know how many elements there are in the lazy sequence is to realize the sequence and enumerate each element and see where the lazy sequence ends or stops, and at that point I know how many elements there are in the lazy sequence. So for the family of lazy sequences related types, counted is false, and the performance profile is linear instead of being a constant time. You can see that the type of this for list comprehension is a lazy seq as expected, a lazy seq as expected. Interestingly, there are counted things that are false, like strings, and this is because counted contract is telling me that the collection, in this case a char sequence, should be a clojure collection to give me the constant time guarantee. If it's not a clojure collection, obviously a Java collection doesn't know about the counted interface, which is only present in clojure, so it cannot be implementing that interface. But a string or an array are both things that can be counted in constant time. So despite the fact that it's returning false, this is still a constant time count in clojure as well. And there are more interesting cases that we are going to see if we go back to the slides that I collected here. So this is a very good summary of most of the clojure types that I collected here. There might be a few more permutations here that are not listed, but these are the most important for this discussion. So what this table is showing is based on the type, if the counted is true or false. It's giving you a little examples of what I mean by that type, and it's giving you the complexity. So for the situation is quite good for all the most popular clojure data structure. Counting is a constant time operation, which is good. There are a few notable exceptions. We already talked about lazy sequences. There is also another interesting exception in ranges. So there are two types of ranges essentially that are interesting for count. One is the long range. So when you do range of 10 or any like integers, that is returning a long range, and that is a count in constant time is a constant time operation count. But if you use something else for the range, then is not what the range function is returning back is not a long range, is another kind of range, a generic range, and that is not counted. So counted is false. Let me see if I can highlight what I'm talking about. So talking about this line here. So counted is false and is still range, but is linear if you try to count. So you might be surprised if you're using a range using, for example, the exponential notation. This is a float, so or a double, and this is returning not a long range, and it's a linear operation if you try to count this. So there might be large differences depending on the algorithm and the application, and you might be surprised, and that is a good thing to take into account. And also calling sec, so transforming a collection into the sequential interface, it's also most of the time is also a linear operation and is counted false, so that is respecting what we expect from the counted interface. But there are a couple of exceptions on this. So sequence called on vectors is a constant time count operation, and also an array maps, which is a specific or a special kind of hash map implementation based on arrays. And also the fact that it's based on arrays let us think that this is going to be a constant time operation. So I think I covered all the topics related to count. As you can see, it was not it's not necessarily a simple function when you start to think about the performance profile and the way it behaves based on all the different kind of collections. So even the simplest count can be surprisingly slow when used in the wrong context or the wrong collection type. Okay, this is it. The show notes will be soon available at this link at the bottom of the slide. And until the next time, I hope you enjoyed the screencast, and goodbye.